When solving polynomial equations degree 3 or higher, it's important to try to get an idea of what type of answers you're looking for, how many positives you're looking for, how many negatives, how many non-reals, or at least the possible number of each of those. And also looking at a list of possible rational roots. A list that if a rational number makes the polynomial equation true, it would be embedded in that list. But we actually get a list that has more numbers in it that make the equation true. It's just all the ones that do make the equation true are somewhere in that list. And the process of finding our list of possible rational roots, remember a rational number is a number can be written as a fraction of an integer over an integer. We can find that by taking all the factors of the constant term divided by all the factors of the lead coefficient. Lead coefficient is the coefficient in front of the first term after you've put your terms in descending order. So the list of possible rational roots is to form a list by finding the factors of the constant term divided by the factors of the lead coefficient. Okay, so here my constant term is 6. The factors of 6 are plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. And the way you can generate this list, especially when the number gets to be something that you aren't as familiar with to factor it, you always go 1 in the number, so 1 in 6, and then you think of the next whole number in 2. Does 2 divide into your number? And if it does, you write it down, and then you think, well, my number divided by 2 is 3, so you also write that in, and you have that as a factor. And here, now that's where they meet, so I know I was done. If there was still a wide span of values between, I would just keep incrementing until I hit where my factor pairs are completing the list. So I have the factors of 6 listed here. The factors of my leading coefficient are just plus or minus 1 and plus or minus 3, because 3 is prime. And then I need to make a list where I do all the combinations of the factors of 6 over the factors of my 3, my lead coefficient. So I'll go 1 over 1, 2 over 1, 3 over 1, 6 over 1 with the plus or minus. And then I'll go 1 over 3, 2 over 3, 3 over 3, and 6 over 3. And sometimes some of those number fractions will simplify, and I will write a final form of the list at the very end. So we have plus or minus 1 over 1, plus or minus 2 over 1, so 1 over 1, 2 over 1, plus or minus 3 over 1, plus or minus 6 over 1. Now we're going to go plus or minus 1 over 3, plus or minus 2 over 3, plus or minus 3 over 3, and then plus or minus 6 over 3. So we have all of those possible numbers. Now let's see what we have in terms of simplifying the fractions. That's plus or minus 1, plus or minus 2, because 1 divided by 1 is 1, 2 divided by 1 is 2, plus or minus 3, plus or minus 6, plus or minus 1/3, plus or minus 2/3, plus or minus 1 again. And we already had that, so we're not going to list it more than once when we do our final list. Plus or minus 2, again, that's another one that we already had. And then that's the ending of our list. Now, something that's helpful is to put this in order from smallest to largest. And we'll do that for the positive choices first, and then we'll just reflect it back for the negative ones. So out of all these numbers, 1, 2, 3, 6, 1/3, 2/3, and then the 1 and the 2 are duplicates. 1/3 is the smallest number. So I'll write 1/3. And then after that, the next smallest is 2/3. And then I'll just mark that I've got those. Okay, and then 1, and I have that as a, happened more than once in there. I have a 2, I have a 3, and then a 6. So that's all the positive possible rational roots in order. And then I also could have the negative one. So a negative 1/3, a negative 2/3, a negative 1, a negative 2, a negative 3, and a negative 6. So I just went and did the negatives in the reflected order so that I can make sure that I have them in order as well. So out of this list, if there's any rational number that makes this equation true, it has to be in this list. However, there are other numbers in this list that don't make it true. So I have to sort out which ones out of this list actually make my equation true. But at least having a limited list to check for the rational numbers was better than not knowing at all where we should go to try to find our rational roots of this polynomial equation.